topic under discussion is about the hydroxychloroquine. In our this discussion, we'll talk about the entire medicinal of the hydroxychloroquine. We'll talk about that. What is this actually? We'll talk about what is this. Yes, means we'll tell you people about the antimalarials. Then we'll talk about its class, where it is from. Then we'll talk about the structure, IUPAC, mechanism of action, IUPAC naming, okay, SAR, therapeutic use and synthesis, and some other points will also be discussed in the entire discussion. So let's get started from the very first point, that is, what is hydroxychloroquine? It is actually one of the antimalarials, and more specifically talking, it is from the 4-aminoquinolines. It is from the 4-aminoquinolines. Now, what is 4-aminoquinolines? First of all, let me clear this point. 4-aminoquinolines. Simple. We have this structure. So if you see this structure, this is actually named as quinoline ring, and with this, if on 1, 2, 3, and 4th position, if you find hereby amino group, then it is named as 4-aminoquinoline. This is actually the 4-aminoquinoline. Why? Because on 4th position of the quinoline ring is amino. That's why it is called as 4-aminoquinoline. On the 4th position of this ring is an amino group. That's why it is called as 4-aminoquinoline. I hope you got. Well, then this hydroxychloroquine is actually from the 4-aminoquinolines. Means that you will find this structure in the hydroxychloroquine structure. Now here is the structure in front of us. In this we have the quinoline structure having the amino group. That's why this is actually from the 4-aminoquinolines. So now what is the class? Simple. The class of the 4-aminoquinolines is, it is actually the class of what? It is actually the class of the hydroxychloroquine. So what is the class of hydroxychloroquine? The class of the hydroxychloroquine is 4-aminoquinolines. Well, so we got till this place. I hope you got the entire discussion till this place. Now let's come towards the structure of the chloroquine. What one? Hydroxychloroquine. Now how to draw the structure. Now here I will tell you people about how to draw by means of a trick. So I will tell you you guys to memorize this trick name. Through this trick name, then you will become able to write this structure in a very easy way. So now what is the trick name that I have given to this hydroxychloroquine, through which I am actually able to draw the structure in an easy way? That name is actually simple. I call this hydroxychloroquine with this name, hydroxychloroquine dip. Now what is this dip stands for? Simple. Diethyl amino pentane. Well, so this is the trick name. If you ask me what is the structure of the hydroxychloroquine, I will tell you the trick name through which you guys will become able to draw the structure. And I'm able to draw the structure because of this trick name. So now how I'm drawing, just concentrate the board. While looking the trick name, I'm going to draw the hydroxychloroquine structure in a very easy way. Yeah, easy way, because it's easy for me and for my students when I just go this way for them. Coming to the point. Looking this, just draw the structure. Hydroxychloroquine. Yes, one more thing you must remember. Whenever you are drawing the hydroxychloroquine, you must remember that this hydroxychloroquine is from the 4-aminoquinolines class. So 4-aminoquinoline is actually the main component, the main point. This is actually the parent ring, you can say. So you must remember the parent. So first of all, instead of going through this, first of all, you must draw the parent structure. That is 4-aminoquinoline. It is from where? From the 4-aminoquinoline. Simple. On 4th position, amino group. Now, come towards the name, trick name that I have given to this drug. Hydroxychloroquine DEP. So here is hydroxy, means we have the OH. Then we have chloro, Cl. Quine is actually the quinoline ring. Here is the quinoline ring available already. Then we have DEP, diethyl aminopentane. Now first let me draw this for you guys. Here, here, 1, 2, 3, 4, 5. So we got 5 carbon, pentane. With that you will have nitrogen. With that you will have C2 H5. This is actually the diethylaminopentane. This is actually the diethylaminopentane. Diethylaminopentane. Now, what you are supposed to do is look at the name, just complete the structure slowly and gradually. We have hydroxy. First of all, for now, guess what? Hydroxy, just keep it aside, and you must try this with the DAP. Okay, hydroxy must be with the DAP. So next, what remaining is the chloro. So chloro must be here, and then we have queen. So we have quinine ring here. Just complete the valencies. This is the quinine ring. Then we have DAP, diethylaminopentane, this structure. Now just take this structure and put it here, replacing this hydrogen. So you will get like this structure. Carbon having 1, 2, 3, 4, 5. With this we have nitrogen. With that we have C2H4OH. Forget about OH for now, because I'm going to give you the idea. So what do we got now? Simple. Quinoline ring with the chloro, with the amino, 1, 2, 3, 4, 5 carbon chain, pentane, with which we have nitrogen, with that we have C2H5, CH5. Now what is remaining? That is hydroxy group. So hydroxy group, I told you it should be with the DAP. So just remove one hydrogen from here and make it C2H4 and attach to it hydroxyl group. So like this, you got the structure of the hydroxychloroquine. So how I got the structure? Just recapping the entire mechanism pathway in simple one line. I told you before going to draw the structure, you must give this hydroxychloroquine a trick name that I have told you. That is actually hydroxychloroquine DAP. By means of this name, you will easily draw the structure of what? Hydroxychloroquine. And as you start drawing, you must memorize that this hydroxychloroquine is actually from the 4-aminoquinoline. This is the class. You must memorize the class. Okay, this is actually the parent name, the parent chain in the class. You must remember this. Remember this. Okay, remember. Now just dot it here for the first time. I draw here. After that, I just started going through the name that I have given to this drug. That is hydroxychloroquine DEP. Hydroxy is here, chloro is here, queen is here, then we have DEP, diethylaminopentane is here. So I told you guys, when you just draw this entire and practice this time and again through just this single one name, one modification, that is actually the DEP that I have done while just memorizing, or you can say going through the structure of the hydroxychloroquine. So I hope you got the entire mechanism and the entire steps. If still you have confusion anywhere, feel free to ask us in the comment box. And now let's come towards the next point, that is the mechanism of action, IUPAC, and points are actually SAR, therapeutic uses and synthesis. So coming to the mechanism of action. Regarding mechanism of action, it is believed that whatever is present in the vacuoles of the plasmodium, so it goes inside there and changes the pH. Hydroxychloroquine is changing the pH, whereby because of the change in the pH, the cell actually destroys. This is the short, brief mechanism of action. And one other mechanism is that it is actually interacting with the heme. It is producing the heme. So no, it is making the area for the heme free. So it is actually inhibiting hemozoin formation. And at the end, if the heme is available, so we have got this concept in our early lectures, in our early classes, in the life cycle of malaria when we were talking there. So if you don't know the life cycle of malaria, please watch that video also for your concepts. And if you're getting the concept here, it's okay. So when the heme is synthesized, this heme is actually then converted into hemozoin by the plasmodial plasmodial enzymes. Okay, those enzymes are converting the heme into hemozoin. Now this hemozoin is causing fever, anemia, and splenomegaly, etc. in our body. So what we are doing when we indicate hydroxychloroquine, chloroquine, etc., most of the drugs, they are actually interacting with the heme. So heme will be then free, then it won't be converted to hemozoin. So if the hemozoin is not formed, not synthesized, then fever, anemia, and splenomegaly, whatsoever the symptoms of the malaria is actually, those are actually lost then. Then what is actually seen, then the heme will start doing its job, that is to lyse the plasmodial parasite. So you can say, one can say also that it is actually breaking or doing the lysis of the plasmodial parasite, means it will cause the death of the plasmodial parasites. So like this, the mechanism of action is actually getting to the end. Now let's come towards the IUPAC. Well, what is remaining? IUPAC, SAR, therapeutic use, and synthesis. +923408060081. Ask here for this particular portion. We will give you and we will tell you people the where is this portion and how you can do have an approach for this part.